Welcome to our 13th and final lab this semester for our Chem 1211 lab here at North Georgia. This week what we're going to be taking a look at is Charles' Law, which is basically the relationship between temperature and volume for gases. And so we're going to try to verify Charles' Law experimentally this week. And the way we're going to do that is we're going to be taking these flasks, and what we're going to do is basically take these flasks where they have a little side arm to them with a hose. We're going to heat these things up while they're covered with the rubber stopper like you see I have going back here. And this general setup is what you see kind of in your general lab procedure. You might see a Bunsen burner shown in there. It's probably easier just to use a hot plate since we're doing a hot water bath anyway. And so I kind of took the leisure of setting this up ahead of time and heating it so you don't have to sit here and watch a video of water heating up for 15 or 20 minutes for it to get boiling and get our flask up to temperature and everything. So what we're going to do, I've already gone through and been heating this flask now for a while, and you notice this hose in the back is open, right? That's important. We want the hose open if it's stoppered on the top, because otherwise if this hose is not open, if everything is closed, you have a closed volume. Well, one of the other gas laws is as temperature goes up, if volume is constant, pressure goes up as well. And if the pressure gets too high, you can blow the cap off on your stopper at the top of your flask. That's what you want to try to avoid. So during heating, you're making sure that your flask is open through the hose portion in particular. And then what we're going to do is, as I'm ready to kind of make my measurements, what I'm going to do is measure the temperature of the hot water bath with the thermometer that I have here from our LabQuest. I'll measure the temperature of the water. And then what I'm going to do is, once I've measured the temperature of the water, I'm going to quickly lift the flask out of the boiling water bath, and then I'm going to go ahead and clamp off the hose. So I'll like bend and use a little clamp that I have sitting over here. I actually need to figure out what I've done with. I actually ended up leaving it in the ice bath from the first trial that you'll see data for on in a little bit. And I'm going to use this clip to basically help close off the hose so that as I take my hot flask and put it into the cold ice bath, I'm going to leave things kind of clamped off. So what's going to happen is this flask, as everything is kind of closed, if everything is closed, putting it in a cold water bath or ice bath in this case, the temperature goes down, the pressure inside the flask is also going to drop. And after it's kind of sat in the ice bath for a couple minutes, I'm going to open it up. What's going to happen is, because the pressure dropped in here, it's going to suck some water in as long as I keep the flask angled relatively like this. If I tilt it this way, it could cause a problem, especially if I tilt it all the way this way. Gravity could pull some of the water in and make the measurements a little bit wonky at that point. That's what we're trying to avoid. So as long as I keep things kind of held like this at an angle, it should just be the pressure difference that pulls in water. And what I should be able to do is measure out the volume of the water that gets pulled in. And whatever volume the water pulls in, I can subtract that from whatever the total volume of air is that I can fit in this flask to begin with, which is actually the last thing that I'll measure in this experiment. So what I'm going to do at this point, I'm going to go ahead and basically just demonstrate the full procedure for one trial. This will be the data that you'll use for trial 2 that you'll actually see emailed out to everybody. And then I have the data from trial 1 that I've already recorded from a run that I've already done that you'll also get in the email I send out. And you can use all of that data then to do all the calculations that you need for this experiment. And so there are only kind of those couple measurements, right? We'll have basically a hot temperature, a cold temperature, a volume of water that got pulled in the flask, and the total volume of the flask. And we'll have those 4 measurements for each trial, and those are our only real measured values that we're going to need. All right, so for this thing, this has been heating for a good long while. If I want to know what's the temperature of the hot air inside my flask at this point in time, what I'm going to do is I'm going to go and take my thermometer, I'm going to put it in this hot water bath, boiling water boils at 100 degrees. It's probably going to be a little bit less than that generally. These hot water baths have a hard time getting all the way to 100, so mid to upper 90s, pretty common. You can read the temperature on the thermometer. It's getting pretty close to that now that it's sat in here for a minute. I'm going to let this sit here for just about a minute longer just to see what temperature it actually kind of stabilizes at, and if it like stops rising. You see it actually kind of plateaued already, got up to 98.5, it's come back down a little bit. So I'll hold it in here just a little bit longer, but it looks like about 98.2, 98.3. I'm going to call, well, kind of bounce around a little on me again. Say 98.2, that seems to be the midpoint of the region it's kind of bouncing between. Actually, it's pretty stable there, so I pulled out 98.4. So let's just go 98.4. If I want to be really accurate, I could probably leave it in and take an average over a period of time. I'm not going to do that to show for the video. Simply from kind of a time standpoint, I don't know if people just sit here and watch long periods of time as I do things. So we'll say 98.4. I'll write this down here. That's going to be our hot temperature, and that's in degrees Celsius. But you'll want to remember, as you go to do your calculations, you'll need to convert that to Kelvin for all these ratios. Right? Anytime we use an actual temperature in any calculation, has to be in Kelvin. We can only use Celsius if it's like a change in temperature, like a delta T that's involved in some equation. All right, so the next step of this, I'm gonna remove this from the hot water bath. Make sure my flask is still clamped down good. And then I'm gonna go ahead and close my hose, or pinch it tight. So I'm gonna pinch my hose down here near the end. I'm gonna use this clamp to kind of hold it in place so that it's closed. And now what I'm gonna do, rather than stand here and just wait a long period of time for my flask to get cool enough for me to grab the flask with my own bare hand, I'm just gonna take the whole clamp off of the ring stand. And this will also be easier because I'm about to dump this thing in an ice bath, and I've seen people in the past, students that basically have waited for the flask to cool down, then grabbed it with their bare hand, and then held it with their bare hand in the ice bath for like 5 minutes. That's miserable. It takes a lot of extra time, and holding your hand in an ice bath for that period of time is really miserable in particular. And so leave it just in the clamp, and what we can do now, like I said, I'm going to invert it at that angle downward. I'm going to go ahead and submerge it into this ice bath, and I'm just going to hold it here totally submerged in this ice bath for a couple minutes. Then I'm going to go ahead and open the flask up. I usually do not open the flask right away. I think even actually the directions say to do that. I've generally seen better success from students in the past. If you go ahead, put it in the ice bath, let it get cold, kind of like let it equilibrate temperature-wise, then open it up and let that pressure difference pull in the water at kind of that inverted angle. That tends to work fairly well for most people. And if everything goes hopefully according to plan, we should see our flask pull up somewhere in the range of maybe 30 to 50 milliliters of water, depending on what its total volume is. So that's kind of our ideal target range, hopefully, of how much water is going to get pulled in when we go to do this. But I'm going to give this another kind of couple minutes to equilibrate kind of temperature-wise. And while that still equilibrates, I'm also going to get a temperature for this cold water bath. So we had 98.4 was our hot water bath temperature. I'm going to use my thermometer here to get a temperature for our cold water bath as well. I apologize for the cut there. I had to switch our thermometers. That one unfortunately looked like it died out on me for a minute. And so measuring the cold water bath temperature, and I've actually checked equilibrating wise, making sure that the temperatures are about the exact same between the two, and they're calibrated within about 0.2 degrees. That's pretty close for what we really need in this experiment. And it looks like sitting here in the cold water bath, I got a temperature, was pretty stable for a minute there, about 2.8, now it's back there. So about 2.8 degrees Celsius. I'm gonna call that my temperature for the cold water bath that I've been holding this flask submerged in for a couple minutes now. And what I'm gonna do is now, once this thing's been submerged in this cold water bath for a good long while, I'm gonna go ahead and open this clip that I had closed. And so I'm trying to keep it inverted as I do this and submerged, so it's a little bit awkward. But there I got the clip to pop off, and the flask open. And I can see some of the water that's now rushed in the flask. I'm gonna hold it here for about a minute longer, just to see how much water actually gets pulled in. And that's kind of the one tricky step as you do this. You need the clip to kind of come off easily without kind of tilting things too much or too extremely, because you don't want gravity to play a role in some of this as well. Usually, as long as, like I said, if you hold it with the clamp, you can keep it inverted pretty well. And especially if you have a lab partner, one of you can just hold it and one of you can unclip, and it'll be much easier probably to do that. All right, so it's been in here a little bit. Now I'm going to go ahead and pull it out. You should see some water that's been pulled into the flask. So we see a good bit of water that's now pulled into the bottom. What I'm going to do now is actually measure what's the volume of that water. So I have my measurements that I've made so far. I'm going to set that there for a second. I'm just going to record that cold temperature was 2.8 degrees Celsius before I forget it. And now what I'm going to do is I'm going to take a graduated cylinder, and I'm actually just going to measure how much water got pulled into my flask. So I can just go ahead and I'm going to dump all of the water from my flask into my graduated cylinder. Right? And it looks like it's a little more water than the first trial, actually a good bit more water. It's also a different flask, so it might end up okay at the end here. But it looks like we have about, looks like 52.4 milliliters of water that got pulled into the flask. It's a little on the high side compared to what I normally see. Normally I see kind of like 30-ish, maybe 40 on the high end for how much water normally gets pulled in. Usually over 60, I tell people to maybe redo it because it's probably too much at that point to be consistent. But here we got, looks like I said, about 52.5. I'm going to write down that volume so we have it for later. And now what I want to do is figure out how much water can that flask hold entirely on its own. So for that, I'm going to go ahead and empty out my flask, my graduate cylinder. What I'm actually going to do is go fill this flask entirely with water. I'm actually just going to do this quickly here with the ice bath if I can, as long as I can avoid getting any ice in there, hopefully. For the most part, right? So it looks like I filled my flask with water. Probably need to, one thing that's a little bit strange about our flask this time, I probably need to pinch clamp this shut as I do that as well. ice cube out of it so that we can try to get this as accurate as I can. So I'm splashing a bunch of water all over, it's okay. All right, so it looks like I have this pretty much full. I'm gonna go ahead and cap this with my stopper at the top, because my goal is I want this entire flask filled as much as I possibly can with water. And then what I'm gonna do is measure how much water that actually is. And it's gonna be more than the 100 milliliters that my current graduated cylinder can measure, and that's completely fine. But what I'm gonna do, now that I've emptied this, I'm gonna go ahead and start pouring into it. And I'm gonna add, and it doesn't even matter, you just wanna make sure you can actually measure it. So I'm gonna record whatever this number is, it's close to 100. Looks like it's about 93.8 right now. And so I'm gonna record that value because I'm gonna add to that what's still left in my flask. So if I pour this out, just pour it back in my ice bath. So the rest of this for a volume, looks like I have an additional about 69.5 milliliters to go with that 93.8 that I had before. And so now at this point I'm going to record those numbers here. And if I add those together real quick, looks like I get a total volume inside this flask of about 163.3 milliliters. So this means I have a hot air volume of 163.3 milliliters. I then also had the measurement of the cold water that got pulled in, which was that 52.5 milliliters. And I'm going to take the difference of those two values to find my volume of the cold air for my calculations. Right, so hot air is going to be the 163.3. Cold air, if I take the difference, subtracting those, looks like it's going to be, what would that be? About 110.8, something in that range. Probably double check that math just to make sure. That'll be then the volume of my cold air. So I now have a cold air volume, a hot air volume. I have the temperatures of each of these that I measured in Celsius that I will need to convert to Kelvin. But now I should be able to get my ratios. I can take the hot temperature divided by, the hot volume divided by the hot temperature, and the cold volume divided by the cold temperature, and compare the ratios. And hopefully they're very similar values to each other. That's kind of the end goal of how we're trying to verify Charles' law. We're hoping to see a percent difference that's fairly small, and hopefully those numbers then will come out kind of giving us that. And we'll have trial one's data as well to kind of go with that. You can compare out the two trials, which one did maybe a better job. But that's really it in terms of all of the experiment for this week and all of the measured data that we're going to need. So I will have an email that has all of that data summarized for both trials. Right? Normally, if you were here doing the lab yourself, you would do 2 trials on this. I only demonstrated one from just kind of a time standpoint, so you don't have to watch the whole thing over again. And that way you can just see the data in the email that I send that has everything you should need, as well as a barometric pressure, which you might be involved, or at least asked for as well. If anyone does have questions trying to go through the calculations on these, the lab does a decent job of walking you through them, but by all means, if you need help, reach out to myself or other normal instructors. We'll be more than happy to help you on this as need be. And hopefully everyone's managed to kind of survive this weird, crazy into our semester here that none of us really anticipated. And hopefully everyone's been able to at least kind of adjust and at least make it through and kind of bear our way through the hard times. I know we all as faculty miss having you here in person. We would much prefer to be teaching in-person classes as well. Hopefully by fall, everyone will be back and we'll at least be back to some semblance of normalcy at some point. And hopefully we'll get to see you all then. Until then, everyone have a good summer and hope to see you then.